live or not. Apparently not yet. I don't know how long does it take. OBS is a bit glitchy. Okay, now we should be live. Just pop it on Twitter. It's still buffering what I said prior. Give me a second, just in case someone wants to join in. We'll pop it off. On Twitter and LinkedIn. That's the only social media we really use at the moment. It's offering me to post in, what is it? A group, a LinkedIn group called Analytics and Artificial Intelligence AI in Marketing and Retail. No. Don't mind any of the other groups. The other problem is that they're being heavily moderated, so it takes whatever 2 weeks to actually get your post visible to anyone. It kind of defeats the purpose, especially if you're doing live streams. Let's turn the light on. So I have a proper microphone, but no proper light. And that's why you see me, tiny me, on the screen. Just move this a bit. So I'm not actually utilizing my screen space properly. We had that other guy next to me here that we can bring back. Hopefully it doesn't mean messing around with cameras and the like. Yes, that was that first project, camera, face, hand, finger recognition, remove background. That's not the topic of today. While we wait for people to join in, I can look into getting it to work again, because still obviously it's all in the testing mode. I had problem with that code. So we had this 84 lines of Python script. It's using media pipe, some sort of Google's tool, holistic model for it can do pretty much anything, hand, body, finger, hand, face tracking as well. One problem I had is with the video capture. It's the camera that is being used. Yeah, it did turn on the second webcam. I'm getting a timeout. Webcam is still on. Delegate for CPU. Just increase CPU performance for a sec. Someone didn't join in and left. That's okay. Maybe they're probably watching other videos right now. can actually tell. I don't know who you are, but yeah, you can see. Yeah, while live streaming, you get your other content watched as well. So that's good. Yeah, I can't get this one to work. I'm lucky my first camera is still up and running. I think the camera didn't close correctly. Um, by the way, someone was saying on LinkedIn now, actually, like super allegedly a Google AI engineer asking GPT to compute a seventh root of 3 in the power of 7, and it was getting like 4.1 or something like that, saying, oh, yeah, obviously, ironically, how great GPT is at math. So to any Google AI engineers who spread fake news about GPT, I'm not a GPT affiliated, can't care less about what you say. But no, it is working perfectly fine, mainly because it's using Python. And Python can definitely do maps. All this rhetoric about, ChatGPT cannot do math or something, just outright fake news. So both GPT 4 and GPT 3 was able to do it. Simple mathematics. It actually understands um, the whole premise of a language model not being able to do math. Okay, so Python does the math for it, so that should work perfectly fine. Question is if it was able to translate your sentence into what needed to be done. And yes, the session have expired, and this here indicates how it's actually do it. So it's and it did translate it correctly into equation and gave a correct result. So don't believe anything you hear on social media. That would not be a surprise, but it is a surprise that some fake news coming from an AI engineer working for Google, supposedly. Well, that's at least what their LinkedIn profile says. So start a new chat. We do have, yes, they now introduced the Bing, supposedly connected to the internet. I mean, you can use it through Bing as well. I don't know why would you pay for this. And the advanced data analytics is essentially the same. It looks and feels exactly the same as the code interpreter. They removed the code interpreter, but that's the one where you can actually upload files to it. But that also means that it does the bulk of the work on the server itself, which I'm less fond of. I did try some of the plugins, they're a bit hit and miss. There was the codulator that meant to connect your Visual Studio Code to GPT. That did work. However, the codulator does something with the code. For example, it cannot read more than something like 50 or 100 lines of code. I think 50, which is quite unfortunate because some of my code is quite large and it's having trouble to get the context. So it's essentially not basic GPT doing your coding, but some sort of another algorithms that is sitting on top of it using the APIs and stuff. So again, not sure why am I paying for it. Yes, it's nice to be able to connect to Visual Studio Code directly, but but the coding that GPT-4 default version does is much better. So let's pop this error, see what it says.
Here are some steps to diagnose and potentially fix the issue. Ensure that your webcam is properly connected. You can list all connected video devices using the following command. Sometimes the issue can be related to permissions. Make sure your user has permission to access the video device.
Right, so let's try that. And why on earth do we have so many of them? Two of them are duplicates of one another, something.
Here are additional steps to take given the multiple video devices. It looks like you have multiple video devices connected to your system. The warning you're seeing could potentially be due to trying to access a video device that is either in use by another process or not connected properly. If your code is trying to access dev video 0, try changing it to dev video 1, dev video 2, or dev video 3 to see if any of those work. For example, in Python with OpenCV.
We are using Python, OpenCV, CV2 video capture. So the 0, 1 didn't work. Apparently we have 3 and 4, didn't know about. Well, that says the index out of range, so what's up with that? Suppose we have 0, 1, 2, and 3. We won't be spending much time on this.
Based on the error messages, it looks like the script is trying to access a video device at dev video 2, but it's unable to open the camera by that index. This could be due to a number of reasons like the camera not being connected, the camera being used by another process, or permission issues. You can check the connection status of dev video 2 using the v4l2ctl command as follows. This will provide detailed information about the camera if it is connected properly. Ensure that your user has permission to access dev video 2. You can change the permission using the chmod command. And then try running the script again. You can check if the camera is being used by another process using the lsof command. If another process is using it, consider stopping that process before running your script. If dev video 2 is not working, try changing the camera index in your Python script to access another camera. For example, make sure the camera corresponding to dev video 2 is properly connected. Try disconnecting and reconnecting it, and then run the script again. Ensure that the Python script /home/ubuntu.
Yeah, it's always like disconnecting and connecting, it works. But it messes up my other USB connections like microphones. Yeah, USB have this wicked that on a panel, if you have one USB connector, it's working okay. But if you have multiple of them, they affect one another, so they're not independent from one another. So you have to be careful when you, if you have multiple things connected and you need them to work. Once you disconnect one, it will cause trouble. And now I think it didn't close correctly. I have to check how. Anyway, now I'm just confused. But as long as my main camera works, it should be fine, and we'll just move on without the stick figure guy. Just another comment. So before we start to main development, Sorry for the birds. So we have this bunch of tools on biomedical.com. As you know, please go check them out. Give me feedback. I would like to hear how did you go about using any of it. Some of them do not work. We are quickly bringing them back. About 2 tools per week or so. Hopefully it should be like 1 per hour, but doesn't work that well when you ask GPT-4 to code for you, but that's okay. It's better than not having anything. So I have those. These two are relatively new, still work in progress. They will now. We have ECG game, wavelet image compression works in VSF noise, shows examples of different noise types. Have synthetic EEG signal generator that works. It doesn't look like that anymore. We have to change this image. Yeah, also using a new color scheme. We have ECG waveform simulation. ECG. Okay, we'll touch on that in a bit. Yeah, this one doesn't actually do much. Simulates, visualizes. So it doesn't actually simulate. Yeah, we have to combine these two ECG waveform simulator or signal generator with this one. Probably be one and the same. This one doesn't work. It had all the descriptions there. This is the one we would like to focus on today. Yeah, particle motion works and speech rate and volume analysis works only in Chromium-based browsers. So there should be a note there. So before you complain that it doesn't work on Apple devices or browsers, well, yeah, Chromium only. So your Edge, Chrome, obviously. Pretty sure it works on Firefox as well, even though it's a different engine again. So looking at this tool now, we have, let's close. Well, before we do it, and another thing we will be doing is this music, turning EEG into music. There's various reasons for it, not only for fun, even though it arts is not just fun. There's a lot of benefit to arts, but in this case, yeah, the general idea is still ironing it out. Will be an extra tool where we load a pre-recorded EEG data of an actual subjects with epileptic seizures, non-human subjects. Data recorded quite some time ago, probably 2014 or so. Not by me, by another group in the US. We have 16 channels in that does that, so there will be an option to select the channel and convert that EEG into sound waves. So you could explore how does EEG sound like. Then these recordings have seizures, as I mentioned, so you could also check how seizures sound like. Doesn't sound anything like music. and this has some clinical relevance here, is predicting seizures possible while listening to EEG music. So most of the time EEG technologists have to go over hours and hours, days, months worth of EEG recording and label them. Could they just listen to music instead, listen to EEG music instead? So brain, like using your brain to listen to other brain activity, electric activity. Now potentially we'll have option to add more channels and potentially was it turn them, render them, whatever. I don't know what you do. You use the word render in music? Essentially make them sound as different musical instruments. So potentially it will sound more like music or less like music. I don't know. And we'll have some option to do listener rating, so we can use some deep learning and eventually make a music language model, EEG music, EEG MLM. But yeah, if you have any ideas on that, or you want to collaborate, or you know of anything that's already doing it, I'm sure there is something, but then how well is it doing it, or how would you improve on it? I'll be more than happy to hear your thoughts. And now let's close these bits for a sec. Let's see. So we have a back to ECG waveform. So we have this ECG simulator and ECG generator. I don't know why they are different. ECG sim. Let's close. I don't know what's up with it not being able to view images. Just odd. Very odd, but okay. So I had those prompts from prior. G simulator. It's the ECG generator. So what's the difference between them anyway? I think one, okay, so the main difference is one is running in your browser and the other one has a backend, so it's a Flask application. Flask application. Right, so we have this and we have that. Close the ads. This one doesn't have ads because it doesn't actually work. Right, so this one's just running in your browser, no backend. Just check something quickly. We'll obviously cut this out in the editing. Sorry for that. It's just potentially someone might join in live. Right, so we have this info, we have those prompts. It's the simulator. So simulate, okay, so it does something. Let's quickly move. So create another one, probably this time with a backend. This will be the generator. Now, why is it called feature extractor? It's the wrong one. Right, this one. So we have this description. Yeah, ECG gen. Looks like an incomplete prompt. So why images don't load? So why it's even there? Shouldn't be there, doesn't matter. This is a prompt for. Okay, there's confusion there. It's in the wrong folder. We have that HTML. That's obviously go. These Python files. Pop it. It's obviously EEG gen. So this stuff can go into EEG gen. Ava. Right, and for this one, pretty much can grab all the text. So call it info text. Right. Let's see, synthetic signal generate is a versatile tool, yeah, versatile tool, whatever. ECG waveforms. If customizable controls and various parameters. It enables the generation of realistic ECG signals for educational research and testing purposes. Okay, I actually wrote this a while back, but I know it is what it is. It's not great. They generate offers precise manipulation and of key parameters such as isoelectric, let's do this isoelectric. Allow user to adjust the baseline voltage. Additionally, the PQRS delay and the QRST delay controls allow fine-tuning of the time interval. Different components mimicking different cardiac conditions. The generator provides control over the heart rate by adjusting beats per minute, which can be further enhanced by introducing BPM noise, simulating irregular heart rhythms. Moreover, the generator offers options to introduce synthetic noise sources such as white noise and 50 Hz noise, allowing researchers and clinicians to evaluate the impact of noise interference on EEG signal analysis and diagnostic accuracy. Overall, the EEG signal, synthetic signal generator provides a powerful and flexible platform. Yeah, blah, 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 blah. For generating realistic EEG waveforms while offering precise control over various parameters and noise sources. Okay. Yes, so LabVIEW has an inbuilt example. That will be the description for it. Let's pop this at the bottom. It's ECG. So we have ECG signal types. Okay, as electric voltage, input 0 to 10. It's the second Windows. That would be window size, would it? Don't remember. Seconds? I assume window size. size input from 1 to 10 seconds. Electric voltage. One to 10. This will be, was it millivolts or microvolts? Then we have PQRS delay. Right, that will be in seconds. The delays are in milliseconds. One to 50 millisecond. QRST delay would be the same. 0 to 50 milliseconds. BPM 40 to 140 should be fine. Import those are all the inputs. A BPM noise. This will be millivolts, I assume. BPM noise input from 0 to 100 millivolts. Microvolts. Maybe microvolts. See later what makes sense. We have white noise. A 50 hertz. Should be uniform white noise. We might not need that section, adding different types. Yeah, we'll do it later. Different ECG components and different. Yeah, we don't have to use sine waves. All these requirements. Uniform white noise waveform. Do we want different ECG components and different waveform? Yes, that would be nice. Different types of noise in addition to white noise. Not sure about those values. Right, so that's pretty much a output. Obviously, I don't know if it's obvious or not, but so this outputs, no, sorry, inputs. Outputs is the ECG synthetic waveform chart. Right. I don't know if we have to make it the Flask application or can it run in the browser? I wouldn't know. Start a new chat, default GPT-4. Let's see what it says and go from there. It's a large prompt as it is.
Environmental noise sources, apart from white noise and 50 Hz noise, include options for introducing noise from various environmental sources like muzzle artifacts, baseline wander, etc. Custom noise injection, allow users to introduce custom noise profiles to simulate specific and unique interference scenarios. Parameter presets, include preset options for quickly setting parameters to simulate common cardiac conditions. Scripting and automation, allow users to script and automate the generation of ECG waveforms for batch processing or extended simulations. Data export, enable the export of generated ECG waveforms in standard formats for further analysis or use in other simulation environments. Integration with other tools, allow integration with other medical simulation tools and software for a more comprehensive simulation environment. Annotations and labels, provide options to annotate and label.
So it's general overview of what we need.
The ECG synthetic signal generator, as detailed, is a comprehensive tool that can be vital for various applications, including medical training, clinical research, and the testing of ECG equipment. By allowing the manipulation of a range of parameters and introducing different types of noise, users can simulate a variety of cardiac conditions and scenarios.
Yeah, that's just some generic stuff. Not interesting. So what's for sure is that second prompt, we use the I want to generate do we need a Python application? So we're trying to add this tool on an existing website. Can it run in the browser or does it need a backend? Okay, let's see what it says.
You can create an ECG synthetic signal generator that runs in the browser using JavaScript and related web technologies, or you can create a more complex application with a backend, potentially implemented in Python, that generates ECG signals based on user input from the website. You can use JavaScript libraries such as Plotly or D3.js to generate and visualize ECG signals directly in the browser. The generation of ECG signals would be based on algorithms implemented in JavaScript that take user input from form elements on the web page to customize the generated signals. Quick to load and responsive, as everything runs in the user's browser. Easier to implement and deploy, as there's no need to manage a server. May be limited in computational power and complexity, depending on the user's device. Security concerns, especially if dealing with sensitive or private data, as everything is exposed on the client side. In this setup, the user inputs parameters via a form on the web page. These parameters are then sent to a backend server, could be implemented in Python using frameworks like Flask or Django, where the ECG signals are generated. The generated signals can then be sent back to the front end to be displayed. Can handle more complex computations and generate more sophisticated signals, as it leverages server-side resources. Enhanced security, as sensitive algorithms and data can be protected on the server side. Requires server management and could have longer response times depending on server load and capacity. Could be more complex to implement, especially if scalability and load balancing are concerns. Here is a simple example using Flask, a Python web framework, to create an API that generates ECG signals based on user input. In this example, a post request is expected at the generate_ECG endpoint. It reads JSON from the request, extracts parameters, and then generates an ECG signal based on those parameters. For simplicity, a sine wave is used here as a placeholder. Finally, it sends back the ECG signal as a JSON response, which can then be plotted on the front end using JavaScript. Adjust this based on your actual ECG signal generation algorithm and other requirements.
Okay, let's continue with the Flask application.
Great, let's expand on the Flask application. We'll include more details and a more complex function to generate ECG signals. We'll simulate this with a simplistic model, but remember, in a real application, you'd replace this with a more medically accurate simulation of ECG signals based on the input parameters. Install required packages. If you haven't already installed Flask, NumPy, and other required libraries, install them via pip. Develop the Flask application. Expand the application to handle more parameters and generate a more detailed ECG signal. In this example, I'm still using a simple method to generate the ECG, but in practice, you should use a more complex and accurate method. Front-end application. Create a form on your website to take the user's input for all the parameters you need. When the form is submitted, use JavaScript, or any front-end framework you are using, to send a post request to your Flask API and then handle the response to plot the ECG signal on the web page. Here is a basic example using plain JavaScript and HTML. In practice, you might use a library like Plotly, Chart.js, or D3.js to plot the ECG signal. Running the application. Run your Flask app, and it will generate ECG signals based on the parameters received from the front end. The JavaScript code on the front end takes care of sending the form data to the Flask app and plotting the received ECG data on a graph. This is a basic setup, and you can always expand and customize this according to your specific requirements and use cases. Make sure to replace the ECG generation algorithm with one that meets your needs and test the application thoroughly before deploying it to a live environment.
What the file and the folder structure should be?
The file and folder structure for a Flask application, especially when integrating with a front end, can be organized for clarity and maintenance. Here's a typical structure for your ECG synthetic signal generator application. Static. This directory contains all static files like JS, CSS, images, etc. JS.
Yeah, we don't like the...
/templates/index.html. Your existing HTML code for input forms and displaying the ECG plot. /static/js/script.js. JavaScript for handling form submission, AJAX requests to Flask, and plotting. Modularity. Break down your application into different modules to manage and maintain code easily.
We had the one for EEG cross coherence is the last one we were working on. See what the... We don't need the data because this will be synthetic data. We do like this structure. The folder is called ECG underscore gen. If static, that's obvious. Oops. Script.js templates, HTML, data. Do we need data? I don't know. Maybe not. Requirements, info. Right, can we change? That's weird.
Your current structure. It seems like a directory where you might want to store data temporarily or permanently. Be careful with storing sensitive or large amounts of data. Improvement. Consider how you'll manage data, backups, and potentially using a database if needed. This is your main application file where you define your Flask app, routes, and other configurations. Improvement. As your application grows, consider breaking down this file into multiple files or modules to make your codebase more manageable. This file lists all the Python packages required to run your app. It's used to easily install all required packages using pip install rrequirements.txt. Not a standard file in Python, Flask projects. If it contains sensitive or important information, ensure it's secured and managed properly. Improvement. If this is for documentation, consider creating a docs directory and using markdown files for more richly formatted and organized documentation. This file is used for deploying your application to a server, with a WSGI server like GUnicorn or UWSGI. Error handling and logging. Implement error handling and logging to capture and diagnose issues during development and production. Security. Ensure that your application is secured, especially if it's handling sensitive data. Virtual environment. Consider using a virtual environment to isolate your project's dependencies. Docker, optional. If you are considering deploying your application or sharing it with others, consider Dockerizing it for easier deployment and scalability. Ensure your code, especially in app.py, is well organized, and consider using comments and doc strings to document your code inline. Make use of Python's packaging and modularization features to keep your codebase clean and manageable.
This one is the old HTML that we currently have in production. Just rename it for now. Right, so we have some Python code. Can you generate code for this file? Can you generate the JavaScript code?
Certainly. Below is an example of the JavaScript code to interact with your Flask application. It's assumed that you have an HTML form for the user to input parameters and a div to display the generated ECG graph. This JavaScript code uses Fetch API to make post requests to the Flask server and Plotly library to plot the ECG graph. HTML, index, HTML, form and div for the plot. JavaScript, script, JS, handle the form submission, make a post request, and plot the graph. Explanation. The JavaScript code is listening for the form submission event. When the form is submitted, it prevents the default form submission behavior using prevent default. It then collects the values from the form fields and makes a post request to the generate_ECG endpoint on the Flask server using the fetch API. Ensure CORS is handled if needed. If the request is successful, it expects a JSON response containing the ECG data and uses the plotly library to plot this data in the ECG plot div. If there is an error in the fetch operation, it's logged to the console. You should expand this to handle errors gracefully, potentially displaying an error message to the user. This is a basic example to get you started. You should adapt and extend this code to fit the specific requirements and constraints of your application. Ensure to handle edge cases and potential errors to provide a good user experience.
Expand on the index HTML, including all input fields. Don't know what's up with my microphone.
Certainly. Here's an expanded index, HTML, including various input fields based on the parameters you initially listed. The form now includes fields for ECG signal type, window size, isoelectric voltage, PQRS delay, QRST delay, BPM, BPM noise, white noise, and 50 Hz noise.
Yeah, the labels don't need. This should be somewhere else in description or hover over. But it's okay for now. It's better than no code.
Select dropdown for ECG signal type. Users can choose from different ECG signal types like normal, regular, normal, random, atrial tachycardia, and hyperkalemia. Numerical input fields. There are input fields for window size, isoelectric voltage, PQRS delay, QRST delay, BPM, BPM noise, white noise, and 50 Hz noise with specific min, max, and step values as appropriate. Generate ECG button. When clicked, it triggers the JavaScript function to send a post request to the Flask backend with the user's input values. ECG plot div. A div where the ECG plot will be displayed after being generated. Please note, you might want to add some validations or alerts to inform the user if any of the fields are left empty or an incorrect value is entered, enhancing the user experience. Also, adjust the min, max, and step attributes of the input fields according to your specific requirements.
Okay, why is it not working? Can you generate styles CSS file? So we have the...
Certainly. Below is a basic styles.css file to style the form and plot in your HTML file. You can expand and customize these styles to fit your specific design requirements.
Yeah, we have our own a color scheme. We will apply it in a sec.
The body and HTML selectors are used to reset the default margin and padding. We're also setting a default font for all elements on the page. The body selector is styling the body of the HTML document. It sets a background color and text color. The H2 selector is styling the main heading of the page. It sets the text color, alignment, margin, and font size.
Yeah, we need
the form selector is styling the form. It sets the maximum width, margin, background color, padding, border radius, and box shadow to make the form distinct against the background. The label selector styles the labels in the form with specific color and margin.
Getting 4 of 4.
The input type equals, number, and select selectors are used to style the input fields and drop-down select boxes in the form. The width is set to 100% minus the padding, which is calculated using the calc CSS function. The input type equals, submit selector styles the submit button. The log entry 127.0.0.1, the 10th of October 2023, 12 hours 24 minutes and 15 seconds, get HTTP 1.1 inches 404 indicates that a client, probably your web browser, made a GET request to the root URL of your server running on localhost 127.0.0.1 with the server.
Yeah, it's missing this bit. Where should it be?
Routing issue. There might not be a route defined for the root URL in your Flask app. Make sure you have a route defined for, like.
Yeah, this should be. render template. It's not defined. So we need to import render template. Can just do this. Yeah, let's try this again. Okay, this is working, but we get 404 for the JavaScript and the style. So they're obviously not in the correct folder. Need to define the static folder. Notice, wait, we changed the structure, right? We're using this now. We're using this file structure instead.
Here's how you should modify your HTML to correctly reference the CSS and JS files. Less than link rel equals, style sheet, href equals, URL underscore for, static, file name equals, styles.css, greater than this line of code dynamically generates the URL for the styles.css file located directly inside the static directory, using Flask's URL underscore for function. Less than script src equals, URL underscore for, static, file name equals, script, JS, greater than less than, script greater than similarly, this line dynamically generates the URL for the script, JS file, also located directly inside the static directory. Ensure that both styles.css and script.js files exist and are named correctly. Make sure your Flask app is correctly configured to serve static files. By default, Flask should automatically serve files from the static folder, but ensure your app is set up correctly. Clear browser cache or try a different browser to make sure an old cached version of the page isn't causing the issue. Your app.py file should be similar to this to serve the static files properly. Ensure that these files and paths are correctly set, and Flask should be able to serve the static files without any issues.
Script.js gets 200. Style CSS, because it's using a different folder structure. Yeah, I need to remove that. Need to run it again, even though it's in development mode, but right. So we have the form. Okay, the HTML is working okay. This is great. Can we make sure all the inputs are populated with default values? It's not a great layout as well.
Absolutely.
Also,
You can easily set default values in the HTML input fields using the value attribute for less than input greater than tags and the selected attribute for less than option greater than tags and a less than select greater than dropdown. Here's how you can update your index HTML file to include default values.
Where's the default? Also, how do we make sure all the components are visible on one page?
For the select dropdown, the selected attribute is added to the option that should be selected by default. For input fields, the value attribute is added with a default value that should be pre-filled when the page loads. These changes will ensure that all the input fields and options are populated with default values when a user first visits the page. You can adjust the default values as per your requirements.
This is all this form. Can run it. Oh, did I close? I know I opened it in another. Right, so now they're default values, whatever they are. Right, now we're getting some real issues.
To ensure that all components are visible on one page without scrolling, you can apply various CSS styling techniques to manage the layout effectively. Adjusting the size, margin, padding, and using flexbox or grid layouts can be handy to fit all content on one page. Here's an update to the styles.css to style the elements to fit onto one page. However, depending on the user's screen size, fitting all components without scrolling can be challenging, especially on smaller screens. Reduced padding and margins. Reduce the padding and margins to make elements take up less vertical space. Font sizes. Decrease the font sizes to ensure that the text takes up less space. Flexbox or grid. Implemented flexbox to organize sections in a more compact way. You can also consider CSS grid as an alternative. ECG plot size. Adjusted the ECG plot size to ensure it doesn't take up too much space. Be mindful of readability and usability, though. Visibility. Ensure the elements are still large enough to be easily readable and interactive. Responsive design. Consider implementing responsive design principles to ensure your web page is user-friendly on all device sizes. Media queries in CSS can be used to apply styles depending on the screen size. Testing. Always test the layout on different screen sizes to ensure a good user experience for all users. Always be careful with reducing sizes, as making elements too small can hamper the user experience. Make sure to test the design on various screen sizes to ensure it remains user-friendly. Also, achieving a no-scroll design heavily depends on the user's screen sizes and resolutions. Ensure the design remains responsive and user-friendly across different devices and screen sizes.
Yes, changing this view, changing the form, adding padding of 10, okay, whatever. Margin 10. Auto label margin bottom to px. Okay, that shouldn't make much difference, should it? Font size, no, we don't want reduced font size. Input number select. This shouldn't change much. Then EEG plot 800 height margin. Body should be in the beginning. I'm using a flex this sign now. That should be okay. Right. Come on. ECG plot. ECG plot is way too narrow. Also, can it appear on the right of the input parameters?
Certainly. We can modify the CSS and potentially the HTML structure to make the ECG plot wider and have it appear to the right of the input parameters. We can use Flexbox for this purpose, which allows us to create a flexible layout and align items horizontally or vertically. Here's the updated CSS and HTML. Container div. Wrap the form and ECG plot inside a container div to apply Flexbox styling on them. Flexbox. Used Flexbox in the container to lay out the form and ECG plot side by side. Adjusted the flex basis property to control the widths of the form and plot respectively. ECG plot. Made the ECG plot responsive by setting its width to 100%. The plot will take the full width of its parent container, controlled by flex basis. The height is set to auto to maintain the aspect ratio, but you can set a specific height if needed. Max width for container. Added a max width to the container to ensure that the content doesn't stretch too wide on large screens, ensuring readability and usability. Ensure to adjust the flex basis percentages based on your needs to give appropriate widths to the form and ECG plot.
Can you regenerate the whole CSS file?
Certainly. Here's the entire updated CSS file, incorporating all the changes to position the ECG plot next to the form and optimize the layout to fit onto one page. Body and container. The body and a new container div are styled with Flexbox to center the content and position the form and ECG plot side by side. Form and ECG plot. Adjusted the widths using the flex basis property and made other styling refinements to ensure they fit well on the page side by side. Other elements. Adjusted the styling of other elements like the submit button, labels, and input fields for a compact and clean look. Responsive. The design should be relatively responsive but always test on various screen sizes and make necessary adjustments to ensure a good user experience. Please replace or adjust this CSS according to the specific needs and constraints of your project, and always test the layout on different devices and screen sizes to ensure a good user experience.
Someone joined in and actually has a suggestion. Not only asking where I'm from and things like that. Could it work if you use a grid with 2 columns for the form and the plot? Right. 2 columns for the 2 columns. Well, how about we ask the bot, because yeah, obviously doesn't work now. It used to be better. Well, the main problem. Well, first we want the plot. Yeah, in 2 columns is a great idea. Yeah, thank you, Marlon.
Absolutely, using CSS Grid is an excellent approach for aligning the form and plot side by side. Below is an updated version of your styles.css file, using CSS Grid to create a 2-column layout for the form and the plot.
So have to make sure it's the whole file. Let's use that, or at least try using that. It's shorter, a bit suspicious by like 10 lines or so, but it's okay. It was getting too long before anyway. The other thing is, need to update the HTML. How do I update the HTML to have the grid with 2 columns? I don't know why my microphone is failing, but as long as it's working in OBS,
To update the
it should be
HTML
okay.
to work with the CSS Grid layout, you don't need to change much. Since the CSS is already handling the layout, you just need to ensure that the form and plot are direct children of the container that has the grid display style applied. Here's your updated HTML. I've kept the less than form greater than and less than div it equals, ECG plot, greater than is direct children of the less than div class equals, container, greater than. This is crucial because the grid layout is applied to direct children of the grid container. The CSS styles you applied earlier will take care of placing these 2 elements in separate columns of the grid. No other significant changes are needed in the HTML to adapt to the grid layout, the CSS handles it. Make sure to adapt the CSS and HTML according to your specific needs, and always test the layout on multiple screen sizes to ensure it's responsive and user-friendly.
Yeah, user-friendly. Other input fields. Sorry, we'll stuff it up. Can you regenerate the whole HTML with the bits that haven't changed included? So everything necessary is included. Sorry for that, I have to do it, I can't integrate it. But the main thing that we need to solve is the form is actually not whatever way it looks like. It doesn't work. It's not generating the chart. Check of 12. Internal server error, whatever. Control Shift 5. Problem network response JavaScript at line 19 or 20. It generates everything with no templates and the missing bits. I think so. Let's use that. Why is it much shorter? Okay, Control 5. Okay, now the chart is on the right, so 2 columns as Marlon suggested. But we're getting an error when generating the code. Bum, ba, bum, ba, bum.
The error message indicates a problem with a fetch operation in your JavaScript code, particularly on line 20 in script.js. The internal server error message suggests that there's an issue on the server side, not with the fetch request itself. It's likely due to an error occurring in your Flask app, possibly within the route handling the request. Here are steps to diagnose and fix the issue. Check the terminal where your Flask app is running. It should provide an error traceback that can help pinpoint the exact issue. The traceback will include the file name and line number where the error occurred, along with a description of the error. Review the specific route in your Flask app that handles the request being made by the fetch operation in your JavaScript. Make sure it's correctly processing the request and returning a response. The error type error, can't multiply sequence by non-endive type float, is typically raised in Python when trying to multiply a list, or similar sequence type, by a float. The problem is in this line. This error is occurring because t is likely a sequence, possibly a list or a numpy array, and it's being multiplied by a float. NumPy should handle these types of operations, so make sure t and other variables are defined and used correctly. Ensure that t is a numpy array and that all the involved operations are element-wise. Make sure that BPM and isoelectric_voltage are floats or integers, not sequences. Here's the revised part of the code to make sure it works. NumPy array. Ensure t is defined as a numpy array to allow for element-wise operations with other floats and arrays. Float conversion. Ensure BPM and isoelectric_voltage are converted to float to avoid the type error. Element-wise operations. With t as a numpy array and other variables as floats, the operations become element-wise, and the error should be resolved. Ensure to replace the t and BPM values with actual values based on your application's requirements. If the error persists, review the variable definitions and operations to ensure compatibility and correct data types. Also, always test thoroughly to confirm the resolution of the issue.
By the way, if you have any more suggestions, I would love to hear it. It's an open source project, by the way, so oh, come on, just stop repeating everything I say. Numpy array, okay, so we numpy array, BPM should be float. What is BPM? Float BPM. ECG signal should just now work. It's the same line, is it? Yes. Yeah, when we're getting a signal, it doesn't look anything like ECG, but why does this thing keep scaling to the right? It's a weird thing that keeps scaling. Later we also want to change so that instead of hitting generate ECG all the time, well, there's a couple of issues. Main one, that ECG doesn't look anything like ECG. Second, instead of the generate ECG button, can we update the chart every time an input parameter have been changed? Let's start with that.
If the ECG plot doesn't look like an expected ECG waveform, it could be due to a few reasons. Incorrect formula. The formula used for generating the ECG waveform might be incorrect or too simplistic. Real ECG waveforms are complex and consist of several distinct segments: P-wave, QRS complex, T-wave, etc. You might need a more sophisticated model or algorithm to generate realistic ECG waveforms. Parameter values. The values of the parameters used in generating the ECG waveform might be incorrect or not optimal. Make sure the values of parameters like frequency, amplitude, etc. are set correctly. Resolution. The resolution of the plot or the data might be too low, leading to a plot that doesn't resemble a typical ECG. To resolve this issue, you might want to look into more advanced methods of generating ECG signals, potentially involving the use of pre-existing ECG models or algorithms, or datasets of real ECG recordings. To update the ECG plot dynamically every time an input parameter is changed, without needing to click a Generate ECG button, you can use JavaScript event listeners to detect changes in the input fields and automatically update the plot in response. Here's a basic way to do this using fetch to re-render the plot when inputs change. In your script, JS, you can add event listeners to the input fields. In this example, an event listener is added to all input and select elements. Every time an input changes, input, event, the update ECG function is called to update the ECG plot. You need to fill in the update ECG function with the actual code to update the ECG, similar to what you might have inside the submit event listener for the generate ECG button. Make sure to test thoroughly to ensure that the dynamic updating works smoothly and doesn't lead to performance issues, especially if the ECG generation and rendering are computationally intensive. Performance. If updating the plot is computationally intensive, updating it live with every change to the input parameters might lead to performance issues. Implementing a debounce or throttle function to limit the frequency of updates could be a solution. Validation. Ensure input validation to avoid unnecessary or erroneous updates when the inputs are not valid.
Everything suggested sounds great. Can you update the JavaScript code? just keep generating.
Absolutely. Below is the updated JavaScript code that adds event listeners to the input fields to update the ECG plot dynamically whenever an input parameter changes. I'm also including a debounce function to ensure that the ECG doesn't get updated too frequently, which can be adjusted as per your requirements.
Sounds awesome.
Debounce function. Added a debounce function to limit the number of times the update ECG function is called in quick succession, helping to avoid potential performance issues. Event listeners. Added event listeners to all input fields and select dropdowns. Whenever an input changes, the debounced update ECG function is called, which fetches new ECG data based on the updated parameters and re-renders the plot. Initial plot render. Called update ECG at the end of the script to render the initial plot when the page loads. Make sure to adjust the debounce time, currently 300 milliseconds, as needed, and to modify the update ECG function as per your specific requirements and data structure. Ensure the server-side endpoint, generate_ECG, is set up correctly to receive and process the post request and return the appropriate ECG data in JSON format.
What did it stuff up? Something isn't working. The chat is not displaying any signal anymore. Also, the ECG form keeps changing its width. There are no errors in the console.
Let's address the two issues you've encountered, the ECG not displaying and the ECG form changing its width. Here's the revised code and additional explanations to fix these problems. If the ECG is not displaying and there are no errors in the console, it could be an issue with the data returned from the server or the plot rendering. Ensure that the server is returning the correct DAT format, and you can also log the data received from the server to the console to debug. This can be fixed by applying a fixed width or max width to the form in your CSS. You might also want to consider setting a min width to ensure it doesn't get too small on narrower screens or when resized. Logging data. I added a console.log data in the then data equals greater than section of the fetch call to log the returned data to the console. This way, you can inspect if the data is correctly received and in the expected format. Form width. I provided CSS to give the form a fixed width but also ensured it remains responsive. Adjust the width, min width, and max width values as needed. Remember to inspect the Network tab in your browser's developer tools to ensure that the requests are being made to the server and responses are being received when the inputs change. Make sure the endpoint, generate_ECG, is correctly set up to handle these requests and return appropriate responses.
What's this dead space in there? Where's the form container? Where is it? ECG plot. For a sec. JavaScript. Hello, Santiago. Project looks awesome. Keep it up. The ground. Okay. Thank you. Thank you. I really needed that.
If the ECG is not displaying and there are no errors in the console, it could be an issue with the data returned from the server or the plot rendering. Ensure that the server is returning the correct data format, and you can also log the data received from the server to the console to debug.
JavaScript. Update ECG. It's the same. Is everything the same? Or is it different? Const data, fetch, post, JSON, response, network response, status text, then data, console log data. Let's console log data. Console error, we have the error. It should console array. There's an array. Length 500. There's data. So why is it not on the screen? Not okay. Yeah, we haven't hit actually the limit for the prompts recently.
The ECG not displaying could potentially be due to the way data is processed or passed to the plotly plotting function. Let's refine the JavaScript code to ensure proper data processing and handling. Also, the data you posted seems to be a flat array, but for plotly to plot it, you should typically have an array of x values, times, and an array of corresponding y values, amplitudes.
It regenerated the whole JavaScript.
Flat array issue. It seems the array is flat, i.e., it contains only y values. We need both x and y values for plotting.
Right.
In the updated code, I've assumed this and created x values corresponding to each y value. You need to adjust this as per your actual requirements and data. ECG form width. If the form width is still changing, ensure that the CSS is being applied correctly and that no other CSS is overriding it. Ensure that the CSS file is linked correctly in your HTML and is being loaded. You can check this in the browser's developer tools. Data verification. Verify that the server is returning the correct data. Since you are receiving an array of values, ensure you are handling and plotting them correctly. Form data. Ensure that the form data is being collected, processed, and sent correctly in the fetch request. Verify that the server is receiving and processing this data as expected. Testing. Test every part of the process individually to isolate where the issue might be occurring, i.e., logging form data to console before sending, logging server response, etc. Ensure to replace and adjust data processing and plotting.
By the way, Santiago, if you got any other suggestions, comments, anything, more than happy to get your feedback. Preparing data for Plotly, scatter plot, everything the same. So where the x value is being used over there, const trace. Right. We get the data, we can remove the console log from there. So hopefully it runs a bit faster when we change. Right, so anyway, we got the general thing working on in under 2 hours, a whopping 2 hours. Yeah, but hopefully we got a good template. The chart is displaying data again, which is great. Now, how do we make this look more like real ECG? Do you have any existing models?
Certainly. Generating a realistic ECG signal can involve complex models and mathematical equations to simulate the different waves and intervals that characterize an ECG. The electrical activity in the heart generates waveforms with distinct shapes and features, such as the P wave, QRS complex, and T wave. A common approach to generating synthetic ECG signals is to use models like the McSherry model, ECG-SYN, which is a realistic ECG signal generator derived from actual ECG recordings and is based on a dynamical model of the electrical activity within the heart. The McSherry model can simulate ECG waveforms with control over various parameters, such as heart rate variability, to produce realistic ECG traces. Here's an implementation of ECG-SYN in Python. You can incorporate this into your Flask backend to generate the ECG waveforms. You can include a Python library like NeuroKit2, which provides an easy way to generate ECG signals. First, install the NeuroKit2 package. Then, in your Flask root or another Python file where you generate ECG data, you can use the following code. In this code, we're using the NeuroKit2 library's ECG_simulate function to generate an ECG signal. The duration and heart _rate parameters can be modified as needed, or additional parameters can be added to control other aspects of the ECG signal. The ECG signal is then converted to JSON format, with separate arrays for the X values, time, and Y values, ECG amplitude, and sent as a response to the client side. Please adjust the code to fit into your existing Flask application and to handle the parameters from the client side as needed. This should help generate a more realistic-looking ECG waveform that can be displayed on the client-side chart.
Right. NeuroKit. What's NeuroKit?
NeuroKit2 is a user-friendly package providing easy access to advanced biosignal processing routines. Researchers and clinicians without extensive knowledge of programming or biomedical signal processing can analyze physiological data with only 2 lines of code.
So Marlon says it, and I was thinking that it could be possible to generate ECG data with a simple. Yeah, right. We do have a simple model, so we use them quite a bit. Yeah, that would be a simple model. And yes, you could, with that model, obviously, yes, you could change your window size, your IC electric voltage. Just add noise on top of it. So we could just go from there, which probably makes more sense. Is that what you mean? But yeah, we have that model. That's the link that I shared. Yeah, this one is in production. It's not doing much, but those are actual. It meant to simulate like different amplitudes and different like variations of. So it has like 3 variations and a standard ECG there. This one actually fake at the moment, and we have that in. The problem that so this tool doesn't have a backend, so this is all working in your JavaScript. So yes, for JavaScript it will be simple math. I could do something more complicated on the server side. Yeah, this one just has a basic cardiac cycle, Gaussian. So it has sinusoids for S wave, T wave, P wave, refined R wave. I don't remember what that was. But yes, that will be your basic equations. And that's also what the ECG game is doing. Another basic waveform generator. And it has some abnormalities in it as well and things like that, but yeah, it doesn't look right. It doesn't look super realistic. Mine keeps giving me the normal ones. Yeah, normal ECG, abnormal. Anyway, it has a bunch of variations like this, but they're like preset. There's like 5 or 6 of them. We actually want to do something more dynamic, so you can changing these parameters. Yeah, get something more realistic. So yes, that's a good start. To remember if there was yeah, generating JSON, so it's not plotting anything. Yeah, I have JavaScript. It's actually plotting stuff. So this would be your standalone. So this is available for you. It's in production. Know what that there is all about. No, it's actually it's still, yeah, still has some debugging in it. Debugging in it, but the files are just there. So all the sources. Don't remember which one's which, but size charts. Yeah, essentially these two JavaScripts, they're doing all the plotting. Wait a second. So this is not the Python script. It's only the JavaScript code that does it all. Yeah, it's this. What on earth? ECG data. I don't remember how it works. Sorry for that. Python, HTML. So we have a JSON file. Why is this one? There's data in it as well. We have the Python. Don't remember how it works. I'm pretty sure it doesn't have a backend. Script.js. Okay, where is Script.js? What? Wait, where's the file? It should be. It's crazy. Is this generating? Is the Python code generating a script.js? No. Why can't I see the script.js? I mean, it's being served. It's not doing much. It says some data. Plotly. JavaScript. The index HTML. Right, okay, sorry for that. It's all in the HTML, but there will be some script. Yeah, so the JavaScript is in here. Oh, thanks for trying the game. So I wanted to add more to it. So yes, make it look more realistic, because yeah, it becomes very boring very quickly. I did get to like 1,000 points though. But I know that's because I know what the like what the waveforms are. This bugger all of them, 5 I think, 5 variations, and they're like preset, so it's not doing anything fancy. Yeah, I would like to do like with the current tool. Would like to do like vary things so they look more like abnormal EEG, but there will be essentially infinite number of waveforms generated. But yeah, thank you for. I really like the game. I'm a biomedic engineer, biomedical engineer, I think, and learn how to build that kind of project that you do would have been very valuable in college. When was college? Feels like college was ages ago. I would be surprised if most being learned off YouTube and other sources online. And yeah, some of them are more obvious than others. There's one tricky one that yeah, this one just doesn't have one of the little bits there, but yeah. But I can't imagine why someone will would you play it again? There's like no. You could ChatGPT kept suggesting adding a leaderboard to it, but yeah, I didn't really want to do it. And that will also require like to having a backend or some data being sent back to the server. And by the way, when you play the game, what score did you get? What was the highest score you got? If you were trying to reach a high score. And by the way, there's another trick thing about it that they are 60% abnormal and 40 normal. So if you keep just scrolling without playing, your score will start slowly going down. So it's not fully random. And yes, it becomes faster as you go. So those are all normal, abnormal. Yeah, that was very obvious one. This is the tricky one. Normal, normal, normal. Yeah, so if you don't do anything, the false alarms and misses will start increasing. But because there is more of them than 50, there will be more abnormals than normals, then your score will start going down. Okay, this is crazy fast. Can I replicate 1000? This is really messing up with my eyes as well. Oh, and one thing. Oops, sorry. Okay. The other thing is the refresh rate of the screen makes a difference. So I don't know what it looks like in the video because I only have 30 samples. Okay, I got to 1000, I think. Okay, this it was just random. I don't even remember how to detect the abnormalities. I finished the last year. Yeah, so if I don't do anything, if I like give up and don't click on anything, the score will start going down. In the video, it's frozen at 140. 140. Right, so I have to increase the the what's called the frames per second, FP frames per second, FPS, for this video to work, so it becomes like real real gaming now. Yeah, and the score will start dropping. Hey Anzan, welcome to the stream. I think we will wrap up shortly. But if you have any suggestions, questions, as I said, it's an open source, everything. So, by the way, people keep asking if the code is on GitHub and stuff. And yeah, I actually have a template of a blog about open source, but also the reason for publishing on your own website instead of putting stuff on GitHub. Yeah, I would highly. So that's what GPT wrote for me. I have to rewrite it. Hey Bosch, yeah, I do remember you from LinkedIn. Thanks for liking all my content. It does help a lot, especially because the algorithms start promoting it to your contacts and more people in general. I think you're doing biomedical engineering as well, from memory. So yeah, I have to. How does it look like in my stream? It looks okay. No, it does freezes. Why does it freeze? So it will work fine and then will freeze. That's weird. Yeah, the screen's just frozen in the live stream. It's bizarre. No, as in everything else works. Oh, how did? No, now it's running again. This is if I move the mouse away. So if I'm... So it's running for me, obviously, on the screen. But if I move the mouse... Yeah, if my mouse is on my second display, then it stops rolling. It's really bizarre. Always rooting for you. Hopefully everything turns out to be great. Well, it is great as it is. Actually can't get much better. But thank you for rooting for me. That helps a lot. In the console, it's outputting 1 when there is an abnormality. So I didn't get that question, but outputting 1. So I get 10. This should have... sorry, I can't read myself.
ECG waveform game is an interactive challenge that tests your ability to identify abnormal electrocardiogram (ECG) patterns. In this game, you'll be presented with a continuous scrolling display of ECG waveforms on canvas. Your task is to carefully observe the scrolling ECG patterns and quickly identify abnormal segments. Abnormal segments can include variations in the QRS complex, missing P waves, absent S waves, or no T waves. Normal segments will also be present. To tag an abnormal segment, click on it when it aligns with the cursor. However, be cautious not to click on normal segments, as this will result in a score deduction.
Oops,
Your score
yeah,
increases
like
when
I
you
did
accurately
now.
tag an abnormal segment, but decreases when you mistakenly tag normal segment. As you accumulate points, the speed of the scrolling waveforms will adjust, making the game progressively more challenging. Keep an eye on the score display to track your progress and aim for the highest score possible.
Well, right, so yeah, so it's essentially it's not to do with well, in addition to ECG, it's also mainly to do with showing what's heats, false alarm, correct rejection, misses are. So those are the score goes up and down. It's always moving by 10 points up or down. The heat is every time. Oops. So yeah, so we can restart this one so it moves slowly. Yes, sorry for the ads. So that was abnormal. So this is normal if I no. Right, so yeah, it's not as straightforward, but it's good practice to try and explain. So this is normal ECG. If I do not click on it, I get a correct rejection because I didn't click on normal ECG. Same again, and I get my score up. This is abnormal, so I click on it and I get a hit because essentially it says, okay, you meant to detect abnormal ECG. So when an abnormal ECG is shown to you, it's counted as a hit. You get 10 points. So this is also abnormal because it's missing that bit in front. I click on it, get 10 points. Same here. So say if this is abnormal and I didn't click on it, I get a miss because I meant to click on it, but I didn't. This is abnormal. Again, if I do not click on it, I get a miss. If this is abnormal and I click on it, I get a hit. So this is the simple hits and misses. Then you also have false alarms and correct rejection. So you false negative and true positives and true negatives. Sorry, so you have it's the standard table for false alarm. This false alarm rate table. Yeah, this one. Well, right, so you have those standard, yeah, so this standard table. So you have your signal, response. So if it's abnormal, anyway, it's hard to explain by this. I need to probably create now one of those. But essentially the red ones are incorrect, the green one are correct, because you can respond both by clicking on it and not clicking on it. That's your response. So the type of response, you have two options, to click or not to click. And then the signal is normal or abnormal, and your task is to find the abnormalities. So if this is normal, yeah, anyway, you get the point. But yeah, a lot of students, a lot of clinicians are confused by this, like, and don't actually and can practice for many years without actually understanding it. But yeah, it's relevant to misdiagnosis of ECG. So if you find your ECG to be abnormal, but it's actually normal, then you misdiagnose someone with a cardiological condition when they don't actually have. So you diagnose them with a cardiological condition, but they don't actually have any abnormal ECG. Yeah, like confusion matrix, false positive, true positive. Yeah, so it's essentially the same. You have your true positives, false positive, true positive, true negatives, false positive, false negatives. So yeah, just another way of just another set of terms for the same thing. So your heat will be your true. We can change the page actually straight away to include those. But yeah, your heat is your true positive. Mies is true. Sorry. Heat is true positive, and correct rejection is your true negative. And then false alarm is your false positive. No, false negative. And miss is a false positive. Sorry. Yeah. Yeah, exactly like the confusion matrix. Yeah. Anyhow, but yeah, you were asking, like, back to what we're trying to do now. This new tool is well, yeah, potentially we can use apparently this NeuroKit. NeuroKit is a good name to generate stuff. Question is, how well does it work? Do I have any examples? Example. Do you have physiological data? Yes, no. Do you want to have your I like, if you don't have any data, do you want to have data? I like it when you go, no, I just want to test to learn. Should have said, no, I don't want to learn. Okay, get the point. But then, okay, yes, I want to know how to record it. Well, the other thing in here is you could, so you don't have data, you could generate data, synthetic data. I want to test artificially simulated signals. Yeah, so this will be simulate physiological signals. Let's see. Yeah, there's a lot of stuff. They do not provide warranty, of course not. Yeah, we can try it out in your kit. Yeah, so yeah, okay. Yeah, now you're talking. Are those being generated? So yeah, that's the big difference. You were saying how, yeah, mine don't look anything as realistic as that. Is this, if this is simulated signal? Yeah, that's what I want, because you have this variability in the mine, not just so in the gain they're all the same, but those are actually more variable, so they're more real. You can then also add noise on top of it and stuff. But this is great stuff. I do want that. I need more details on it. But yeah, because you see, yeah, they're showing how a variable ECG, like real ECG, can be. So not mine doesn't look anything as realistic as this. This is PPG signal, yeah, and also you can see all this variability in it in EMG as well. So it's a great tool. Like, if it actually does what it says here, definitely want to try it out. And more, well, the GPT, if it's suggesting me to use it, by the way, it forgets context. So how do I integrate the NeuroKit ECG generation in my code. I'm doing it because sometimes it actually forgets the context of the previous conversation.
Certainly. To integrate the NeuroKit 2 ECG generation into your existing Flask application, follow these steps. If you haven't installed NeuroKit 2 yet, install it via pip. In your terminal, run. You need to modify the Flask group that handles ECG generation to use NeuroKit 2 for creating the ECG data. Here's a step-by-step way to do it. Here's an example of how you can modify your Flask route to generate an ECG waveform using NeuroKit 2. Replace less than your existing code greater than with the actual code where you're generating the ECG waveform currently. In this example, the heart rate, BPM, is retrieved from the request data, and it's used to generate the ECG signal with NeuroKit 2. You can similarly use other parameters from the request data to adjust the ECG simulation as needed. If there are specific parameters in NeuroKit 2's ECG_simulate function that you want to control from the client side, just retrieve those parameters from the request data and pass them to the ECG_simulate function. The ECG data and the corresponding time data are then converted to lists and included in the response object, which is returned as JSON to the client side. On the client side, you don't need to make any specific changes if you're already handling the data correctly. The ECG data will be more realistic thanks to NeuroKit 2, but it's still just an array of Y values with corresponding X values for time. Ensure to adapt the sampling_rate and duration parameters in the nk.ec_simulate function according to your requirements. Also, handle the BPM and other parameters carefully to avoid any potential issues related to unexpected or erroneous input values. Adjust the code snippet above to fit into the structure and requirements of your specific Flask application and client-side code. Make sure to test thoroughly to ensure that everything works as expected and the ECG data is displayed correctly on the client side.
Right. Might need a break before we do that.
NeuroKit 2 is a comprehensive library for advanced biosignal processing in Python. It is specifically designed to provide researchers and practitioners with a toolset for easy and efficient analysis of psychophysiological data, including ECG, electrocardiogram, RSP, respiratory, ETA, electrodermal activity, EMG, electromyography, and more. NeuroKit 2 is particularly appreciated for its user-friendly interface and the simplicity Ensure to go through its official documentation and GitHub repository for in-depth understanding, examples, and potential contributions to the library. Adapt and integrate it as per your specific use case and requirements, and always consider validating the generated signals and extracted features with expert knowledge or real-world data. ETA analysis allows users to process and analyze electrodermal activity, including the decomposition of tonic and phasic components. EMG analysis offers tools for electromyography signals analysis, including amplitude and frequency features extraction. RSP analysis features for processing respiratory signals, including breathing rate and amplitude extraction. Ease of use built with a focus on user experience, offering a clean API and detailed documentation to help both novices and experts. Visualization integrated visualization tools to plot processed signals and results, facilitating the interpretation of data. Compatibility works well with other scientific computing and data visualization libraries like NumPy, SciPy, Matplotlib, and Pandas. Extensibility can be easily integrated into custom data processing and analysis pipelines. First, you need to install the library. You can install it via pip. Documentation. Detailed documentation and tutorials are available on the official NeuroKit 2 documentation page. GitHub repository. You can explore more, including examples and source code, on its GitHub repository. Ensure to go through its official documentation and GitHub repository for in-depth understanding, examples, and potential contributions to the library. Adapt and integrate it as per your specific use case and requirements, and always consider validating the generated signals and extracted features with expert knowledge or real-world data. Certainly. Below is the complete Python script incorporating the NeuroKit 2 library to generate a more realistic ECG waveform. Ensure you have installed NeuroKit 2, NumPy, and Flask using pip. Here is the complete Flask app code. The NeuroKit 2 library is used to simulate the ECG data, taking into account the parameters received from the client side, such as BPM. Error handling is added to catch and respond with any exceptions that might occur during the process. The duration parameter is also considered for the window size. If it's not provided, a default of 10 seconds is used. Ensure the client-side JavaScript sends the correct JSON parameters and handles the received ECG data appropriately to plot it. Also, make sure to adjust the sampling _rate and other parameters according to the actual requirements and constraints of your application. Test the entire application to ensure that the integration works as expected and that the ECG data is visualized correctly on the client side. Apologies for any confusion. Let's ensure we fully incorporate your input parameters. Below is the revised Flask app code that utilizes all the input parameters provided in the client-side form. Extracting parameters. The parameters from the client-side request, BPM, window size, isoelectric voltage, BPM noise, white noise, etc., are extracted and stored in variables. Added an example of how to incorporate BPM noise into the ECG simulation. This is achieved by adjusting the noise parameter in the nk.ec_simulate function. We divided it by 100 assuming it's a percentage, but you should adjust this according to your actual use case and scale of noise. If white noise is specified, it's generated and added to the ECG signal. Adjusted the ECG signal to account for the specified isoelectric voltage. You might need to fine-tune how the noise and isoelectric voltage are added based on your specific requirements and constraints. Ensure to test extensively to validate that the parameters are being applied correctly and the resulting ECG signal is as expected. Consider additional validation and constraints on the input parameters to ensure they are within expected ranges and to handle any potential issues related to unexpected or erroneous inputs. The error message, slice indices must be integers or none or have an index method, is typically associated with trying to slice an array or list with a non-integer index. This could happen if you are trying to use a float as an index, which is not allowed in Python. I'll make sure to correct this. Since I am not sure exactly where in the code this error is coming from, I'll guess it's likely from the part where we're creating the time array t or adding noise. I'll make sure all indices and lengths are integers. Here's the revised part of the code. The int function is used to ensure that values that should be integers are actually integers. Make sure to replace 1000 with your actual sampling rate if it's different, and adjust other parts of the code as necessary to fit with your overall application. Also, it's essential to thoroughly test the application to identify and fix any issues that might arise.
Is that sampling rate too high?
The sampling rate of 1000 Hz samples per second might be high, depending on your specific use case. In practical scenarios, ECG signals are often sampled at lower frequencies, such as 250 Hz, 500 Hz, or similar. Here's the revised code snippet with a sampling rate of 250 Hz. Adjust it according to your requirements. The sampling underscore rate variable has been introduced, set to 250, making it easy to adjust as needed. The sampling underscore rate is passed to nk.ec underscore simulate, so it affects the generated ECG signal. Ensure to adapt the sampling rate as per the specific requirements and constraints of your application. Verify the rendering and performance on the client side, especially if the client-side plotting library or method has performance limitations with higher data points. Test the application thoroughly to ensure that the reduced sampling rate provides the desired balance between data resolution and performance.
Is this the whole Python code or just part of it?
Apologies for the confusion. The provided code is a complete example of a Flask application that should work standalone for receiving specific parameters via POST request and returning a generated ECG waveform based on those parameters. Here's a recap of the complete code.
I keep generating the same thing over and over again. Pretty sure it's the same.
This Python script will run a Flask web server that listens for POST requests on the generate underscore ECG endpoint. It expects JSON data in the request body with parameters to generate the ECG waveform and responds with JSON data of the waveform. You would need to connect this with the front-end JavaScript code that makes these requests and plots the data. Please adapt this sample to fit the broader structure and requirements of your application, and ensure to test it thoroughly in your development environment before considering any form of deployment.
Nothing visible on chart console doesn't show any errors.
If the chart isn't displaying any data but there are no errors in the console, it could be due to various reasons like the data not being processed or passed correctly to the chart, or an issue with the chart configuration. Here are steps to debug and resolve the issue. Ensure that the server is sending the expected data. You can add console.log data in your JavaScript fetch function to log the received data and verify its structure and values. Ensure that the data received from the server is being processed and passed to the chart correctly. You can add additional console.log statements to print intermediate data and verify it. Check the chart configuration, especially the data assignment part, to ensure that it is set up correctly to receive and display the data. Here's how you might adjust the JavaScript code to include debugging logs. Ensure that the HTML and CSS are correctly set up and the chart element is visible and has a non-zero height and width. Sometimes, the chart might not display if its container has a height of 0 or is hidden due to CSS styles. Ensure the chart library is loaded correctly and there are no issues or conflicts with other libraries or scripts. Inspect the Network tab in your browser's developer tools to see the request and response. Ensure that the request is made and the expected response is received. Implement these debugging steps, and it should help pinpoint where the issue might be. Adjust the code accordingly once the issue is identified.
Can you regenerate the whole JavaScript code with the bits that haven't changed, so it's working, so it's all the code that is required?
Certainly. Below is the complete JavaScript code that should work with the provided Python Flask backend. It fetches ECG data from the server when the input parameters are changed and updates the chart accordingly. Ensure you have a chart library like chart.js loaded for this to work, or adapt the code to your specific charting library if different. I am assuming your HTML inputs have specific IDs in a common class as shown below. The fetch ECG data function is called initially when the page loads, and also whenever any input field with the class ECG param is changed. The update chart function is used to update the chart with new data received from the server. Make sure to test thoroughly and adapt the code as needed to fit the specific requirements and constraints of your application and environment.
It removed the debounce function, which we had before.
This error occurs because the script is trying to find an HTML element with the ID ECG chart before the HTML is fully loaded. It means that when the script runs, the element is not yet in the DOM, so document getElementById by ECG chart returns null, and trying to call getContext 2D on null raises an error. A straightforward solution is to ensure the script runs after the HTML has completely loaded. We can do this in several ways. Move the less than script greater than tag to the end of your HTML body. Move the less than script src equals script JS greater than less than script greater than tag just before the closing less than body greater than tag in your HTML file. This ensures the script is loaded after all HTML elements are rendered in the DOM. Wrap your JavaScript code inside a window load event listener. We can use window onload to ensure that the script runs after the
This is a problem. It's like forgot the names that it used itself. The names are now different, so I can either Let's give it the HTML that we have, see what it says.
The HTML code structure you provided seems good. You have a form for the user to input the parameters and a less than div greater than where the ECG plot will be displayed. You are also loading a JavaScript file at the end, which is the correct place to load it to ensure that all HTML elements are loaded before the script runs. Considering you are using Plotly for plotting, and if you still encounter the error cannot read properties of null, reading, get context, it might be because your JavaScript is trying to use a canvas element, which is not needed for Plotly. Here is an updated version of the JavaScript code for working with the provided HTML and using Plotly to plot the ECG data. I've removed the canvas-related code since Plotly doesn't need a canvas element to plot the graph. It uses the less than div greater than with the ECG plot. Added an event listener to the form to prevent the default form submission, page reload, and fetch ECG data when the form is submitted. Make sure to test thoroughly and adapt the code as needed to fit the specific requirements and constraints of your application and environment. Also, ensure the Flask server is running and accessible when testing the front-end code.
The question is, do we change HTML or the JavaScript? There's a lot of noise. Okay, it's doing something more realistic. It's too realistic. It's almost like you placed ECG recording gear, and it's just not working, so you don't get the ECG through it. So it's very realistic case scenario. Yeah, obviously. And now this doesn't work. It's only working with the button. There's noise to it, so it's generating random stuff. Essentially too much noise. Right, so that actually looks more like it. It's the other type of noise. Windows size 10. Now we'll leave that there for a while. Just add a bugger roll of noise. Okay, let's remove the noise. This is odd. Two seconds of ECG. It's looking good. It's looking way better than what I had before. So let's thank you to NeuroKit. That's the logo. Go use it. Like, star, put more stars. GitHub. I logged in. Yeah, give them a star. Can sponsor. Yeah, go look up Dominic. Give him some kudos. Because it's does like some really good stuff. Doesn't actually know how to star. Yeah, give him a star.